and welcome to another soldering video. In this video I will solder this Adafruit I2C LCD and keyboard display shield. So I'll start by taking all of the components out and inspect to see what was in the back. So let's start with the shield components first. We have the board. Everything appears to be labeled. We have resistors. There are three types of resistors, 5 of them. We have, let's see, 6 buttons. 4 of them are for navigation, 1 of them is for selection, and 1 of them is for reset of the Arduino. Since the shield stays on top of the Arduino, it is sometimes difficult to access the reset button, so Adafruit has included a reset button. And we have also this potentiometer, which is used to adjust, well, not exactly the brightness, but much more of a contrast of the display. So it's not exactly contrast, but it works the same as adjusting contrast. And we have some pin headers that will solder both to connect the shield to the Arduino as well as to connect the shield to the LCD. We also have this GPIO. It is MCP32017 I2C GPIO. It will stay here. This shield uses only the I2C pins of the Arduino board, so it uses only 2 pins, one for data and one for clock. Typically, well, let me see, yes, yeah, this would be A4 for data and then A5 for clock on the Arduino Uno and compatible boards. This shield is designed to control both black and white or RGB LCDs. The kit I bought includes black and white LCD, however, the assembly instructions should be practically identical for RGB LCD display. Next I'll pick the good old Rusty and carefully cut the packaging on this LCD. There was a little scotch tape. Let's see what is included here. We have another pin header, we have the LCD, and I am not sure what this thing is supposed to do, but I suspect it is alternative potentiometer to this one. So Adafruit provides potentiometer, which luckily is actually breadboard compatible, so very neat little breadboard suitable potentiometer. You can see that it is exactly the same, around 2.5 millimeter step. So since this LCD was intended to be used with breadboard, they have included it in the packaging. We will not be using this potentiometer with this kit. Instead, we will use this alternative potentiometer, which I believe will be installed right here. So that's what's in the packaging. Next step for me is to go ahead and start assembling them, well, effectively soldering all the components and then install on top of Arduino, and we can try to see if it's going to work. Now I'll go ahead and do the first step of the soldering. Here are 2 4.7 K resistors. Therefore R1 and R2, they're supposed to be yellow, purple, red and gold. And just to be on the safe side, and if you have difficulties recognizing the colors, it is always recommended, in my opinion, to double check with ohm meter, multimeter, switch to measuring resistance, and yes, it is around 4.7. They are not very precise resistors and they don't have to be, since this is not a precise analog circuitry. They're simply pull-up resistors for the I2C interface. So I'll take them out, bend the first one and place it in the R2 location. And bend them a little bit outwards, the two legs effectively of the resistor, the two wires, so the resistor will stay steady in place. Repeat the same with the second resistor. Insert in place and bend slightly outwards. Now I can pick the soldering iron and go ahead and solder the two resistors. Inspect the soldering job. Seems to be decent enough for a software developer. And now go ahead and clip the wires. Relatively flush with the soldering top. I can do minor adjustments. And now I'm quite happy with how the two resistors are soldered in place. Now I'll take the other two resistors, red, brown I believe. They're 220 ohms and they're supposed to be installed on the red and blue resistor location. So I'll take them out and repeat the same procedure. Bending the legs to match the two holes. Insert the resistor carefully and then slightly bend the legs outward while pressing the resistor flush to the board. Repeat the same procedure with the second one. Press flush and carefully bend slightly outward. Then go ahead and proceed with the soldering. Again, I'm quite happy with how the two resistors are soldered, and I can go ahead and cut the extra wires. I'm quite happy with the trimming, and this step is completed. Now it is time for the last resistor, 330 ohm resistor, which will be installed in the green resistor location. It is orange, orange, brown, gold. Unfortunately, the colors are a little bit difficult to recognize. Orange and red are not that far apart. However, I have of course double checked with ohm meter, and this is the only single resistor in the kit, so I am quite positive that this is the right resistor to install in this location. The green LED appears to be brighter than the others, so we use a little bit higher resistance in order to achieve similar brightness, reducing the current through the LED when the LED is on. So carefully solder the resistor. Inspect the soldering job. Don't worry, you can always do some minor touch-ups if necessary. And now go ahead and cut the extra wires, preferably without having them fly all over the place. This step is completed and we have all of the resistors soldered in place. Up to this point, I followed the instructions as provided by Adafruit. They recommended installing the resistors first. For next step, they suggest installing the buttons. But since the potentiometer will be located between this button and this resistor, I think it is better approach to first install the potentiometer and then install the button. This way we will be able to access the button from this side easier, and the same for the potentiometer. If we install the button first, it will be a little bit more difficult to do the proper soldering of the potentiometer, since we have resistor on this side and something else, in this case the button, soldered on this side. So we'll have to solder between the two sides. Personally, I prefer to do soldering from one location toward the outside or from one end of the board toward the other, allowing easy access at least from one angle whenever possible. So in this case, I'll go ahead. I already inserted the potentiometer. Place it upside down. Clean the tip of the soldering iron. Cleaning is important for good soldering jobs. And then solder one of the pins. Melt the solder while pressing the potentiometer in place to make sure it is fully inserted into the holes flush with the board, and then, since it's already in good position, solder this in. Make sure it is really fully inserted. and finally the last pin. If necessary, if we don't like one of the soldering jobs, we can do minor touch-ups. And now, after inspection, I am quite happy with how the potentiometer is soldered in place. Now, I will go ahead and install all the buttons and solder them in place. So let's analyze and decide how we're going to proceed. I'll start first with this button. First of all, as you can see, the button pins are located in such a way that you can insert into the holes only in the proper way without seriously bending the pins. So orientation is quite easy, and you can install, the button is effectively symmetric, so you can install it this way or this way. You can rotate it 180 degrees and it still will work perfectly fine. So it doesn't matter, the button is symmetric. And now I can insert it. Make sure after the insertion it is flush with the board. I'm quite happy with how it is right now. Clean the soldering iron and solder one of the pins. Double check that everything is fully inserted and tension is properly released. Make sure the bottom is fully flush against the board. Go and solder diagonal pin. I recommend in this case soldering first one diagonal. Make sure all tension is properly released. And then go ahead and solder the remaining two pins. So the general rule of soldering is you install the low profile components first, then you move to the higher and higher profile components. From this point of view, the recommended order that Adafruit gave to install the buttons first is correct. However, I made exception since the potentiometer is not that much higher than the buttons and it is a bit difficult to access between the other two soldering points. I decided to go ahead and install it before the buttons, violating the principle of installing lower profile components before installing higher profile components. This exception, however, is not a major issue in this case since the profile is very similar. Insert the next button in place. I can actually go ahead and insert all of them in place since they clip very well into the board. So all the buttons are in place and I can go ahead and solder them. Again, I'll start by soldering only one pin for each of them. to give them one last chance to be adjusted if necessary. Make sure tension is released. And the button is flush to the board. And now go ahead, do the diagonal for each of them. Do one final inspection before soldering the remaining pins. The Adafruit board appears to be of good quality. There was no oxidization. The pins on the switches were also not oxidized, so we have very nice, from what I can see, very nice solders, solder joints. And the buttons are all done. This step is completed and starts to look more and more like should. Now it is time to install the Microchip MCP 23017 I2C GPIO right here on the shield. Very carefully take it out, check the pins as you can see there, which is the standard, bent slightly outwards. So the first step is very carefully to bend them slightly inwards. Well, not slightly inwards, but they should be roughly parallel. And now I can carefully insert into all of the holes if necessary, bend a little bit more. Now all of the pins are in place. By the way, as you can see on the board, there is indication for where should be the first pin. This little indentation here, also marked on the board, indicates that this right here will be the first pin. So make sure you insert it as shown on the picture, with this indentation toward the side with the potentiometer. Insert flush in place. Pin the soldering iron and carefully solder one pin. Make sure it is soldered while fully flush. When you solder semiconductors like chips and stuff, avoid overheating them, so try to solder as quickly as possible to avoid overheating and damaging the chip. So now I go diagonal and quickly solder. Tension is released, okay? The soldering job seems good. And now, after quick inspection, I can go ahead and solder the chip in place. This step is completed and the chip is properly soldered in place. Now I'll go ahead and install the pin headers on the shield so we can connect the shield to the Arduino. The first step is to pre-cut the necessary number of pins from the pin headers. So for this, instead of counting, I'll just insert, well, first of all, this will go right here in this 1, 2, 3, 4, 5, 6, 7, 8 holes on the outer side of the Arduino shield. Right here. Next one, outer slight space will go right here. Again, I'm just inserting into the holes and picking the place where I need to break it. Carefully break. Next one will go into these 6 holes right here, and the next one into these 6 holes here. So 6 pins. Don't worry if you break wrong, we have spares. And the last one right here. And we have some extra. Put the remaining pin headers aside and place everything in place to make sure that it's going to work. We'll install the pin headers on the opposite side of all the rest of the components. To help guide us, we can use any Arduino compatible board, Arduino Uno, shield compatible board. As example, this Maker Uno that I just picked from the desk next to me. We can loosely, well actually I'll go ahead, loosely place the headers in the proper locations. Place the shield on top. This will be a little bit trickier than I thought initially. But with a couple of attempts, I was able to place it properly. So now I can carefully solder one pin for each of the headers. To hold them steady in place, and I'll do more careful adjustments before fully soldering them. Now they're steady, held in place, seem to be properly aligned, flush with the board. And now I can go ahead solder the other end of each of the headers. Make sure they're still properly flushed against the board, fully inserted. Double check that they're still properly aligned with the headers on the Arduino compatible board. And now go ahead and solder the remaining pins. Carefully solder next to this chip in order to avoid shorts. And the last one. And the shield appears to be pretty much ready, except installing the LCD on top. To be honest, I'm a little bit conflicted. It may have been a better idea to install the LCD first before installing these pin headers here, By the way, I don't like this particular solder. I can improve it a little bit. Yes. Now they all look nice and, in my opinion, good quality solderings. So yeah, what I was saying is that the access to this pin header from the bottom will be a little bit difficult, but that being said, it still should be perfectly fine. Well, we'll see. We'll see about this. It will be a little bit tricky. I would have preferred to install it before installing these pin headers, but I went ahead and installed them anyway, so it's a little bit too late for me to be unhappy about it now. We'll make it to work, even though I would recommend you to install the LCD first before installing the pin headers on the bottom. In any case, this step is completed and this looks much more like a shield now. Now I'll go ahead and install this pin header right here on the LCD. Let's take a look at the LCD first. Well, looks like largely a run-of-the-mill LCD, similar to many others that I have seen. So this is the pin header that will send control commands to the LCD, as well as power and control for the backlight LED. All I need to do is take this pin header and break from it enough length for all of the pins here. Next, I'll go ahead and solder one of the pins. As example, this one. Don't worry that the pin header is bent. Now I'll keep pressing it, melt the solder and make sure it is fully flushed against the board. Now I'll go ahead, solder this pin, the opposite one, again press the header and make sure it's flushed with the board roughly perpendicular. This one doesn't need to be super precisely perpendicular, but the closer to perpendicular it is, the better. Looks good to me. And now go ahead and finish soldering the rest of the pins. The pin header is properly installed and soldered on the LCD. Now I'll go ahead, insert this pin header here, By the way, I just noticed that this pin header is longer than, at least the holes for this pin header is longer than the pin header on the LCD. This is because this is black and white LCD, and this shield can control both black and white LCDs as well as RGB LCDs. Unfortunately, I bought myself black and white LCD, so I'll have a little bit less functionality. So the extra two holes here are for the red, green and blue LED for LCD displays that have them. In this case, two of the pins will not be used, so make sure you align, if you have black and white LCD like me, you align the first hole with the pin header here, and you have the LCD flush with the shield like this, with these mounting holes matching. Flip over and solder one of the pins. I'll go ahead and solder this one first. Make sure the LCD is positioned the way we want it. Now go ahead, solder the second one, the opposite side. Seems good to me. And now I can go ahead and solder the rest of the pins. This is the reason, the little space here is the reason I thought it may be actually a better idea to install the pin header on the bottom after installing the LCD. It is not a major issue, but it is a little bit trickier to solder here. The soldering is completed, the shield is ready, and the only remaining thing for me to do is to trim these extra pins here. That's not necessarily needed, however, but I will do it nonetheless. So I'll go ahead and trim them relatively flush with the board. Doesn't need to be super precise. The space is a little bit difficult here with this pin header next to it, but we can manage. Now that they're trimmed, I can do over the soldering just to have them better covered and correct for any cracks that may have developed in the solder during the trimming. Go quickly through them. And at this point our shield is ready. Now I will carefully inspect for bad solders. Like right here, I think we need a slight touch-up. Continue with the inspection. If necessary, use magnifying glass. Hopefully my eyes are still good enough to spot bad soldering job. Right here there is a small improvement that can be done. A little bit more solder will help. And we also will need to pay attention for potential shorts or solder that has splashed around. Looks good to me. I'm not going to wash this board, at least not now, but it is recommended to use alcohol and clean the extra flux from the solder. That, however, usually with good quality flux, should not be a problem if we leave it in place. I have already added support for the shield in Visuino, and it will be included in the next Visuino release. Once the version is released, you'll be able to click on this button, select Add Shields, and you will be able to find the shield included here. It is the Adafruit LCD 5-button Keypad I2C shield, and if you have the RGB version, you can also select instead the RGB Light LCD 5-button Keypad I2C shield. Whichever version you have, select it and click on this button to add the shield. This will add all of the shield functionality on the Arduino board, and all of the settings will be available here for you. This includes both the display and the keys. Now I will show you the test project that I created for the shield. I have used a standard Arduino Uno board. I have added the bouncing button on select, and I have added a T flip-flop to switch between flashing and non-flashing for the display. The flip-flop is connected to enable pin for the pulse generator. I added the enabled pin through the visual light bindings by clicking on this pin at front of the enable property and selecting Boolean sync pin. For the display, I have added also pin for the backlight property. Again, it's a Boolean sync pin. The pulse generator is connected to the backlight, and if the pulse generator is enabled, it will start flashing the display with pulses. For the pulse generator, I have set the initial value to true, and when disabled, I have set it to reset, so when the pulse generator is disabled, the display will be automatically turned on. This covers the flashing functionality. To display the different information for the shield, its display, I have added two elements. The first is a text field element positioned at row 0, and the second is integer field element positioned at row 1. For the integer field showing the counter, I have added a clock generator with default settings and a counter also with default settings. Connected the clock generator to the in pin of the counter and the output of the counter to the input of the integer field. For all of the buttons, I have added text value elements. For each of them, I have set the corresponding select, up, down, left, and right text. So whenever we click on one of those buttons, when we press them, the corresponding text will be sent out. All of those outputs are connected to the text field right here. So that's the entire project. It took me about 5 minutes to set it all up, and now I can go ahead to the Build tab, select the COM port where my Arduino is connected. It is already connected to the USB port, and now I can click on this button to compile and upload the code. The code is uploaded, and now I can go ahead and test my shield. Now I can go ahead and test to see if I have soldered everything properly. I will use this MakerFabs Uno Arduino Uno board, which is Arduino Uno compatible board from MakerFabs. The pin headers are identical, so I will carefully plug the shield. Went in nice and smooth. And now I will connect power. I have already programmed the Arduino Uno with Visuino to control the shield. I have done the full mapping, and I have set a simple program. I will post the code below the video. It is quite easy to do it with Visuino, and you can use the free version of Visuino to program with this particular shield. I have added the shield support as a free component in the Visuino. So here we have a counter shown in a field of the display. I can press the different buttons. Every time I press a button, it will send the corresponding text to the shield, and it will stay there until the next button is pressed. And if I press the select button, I can switch between flashing mode. Here I was testing the backlight. The first time you install the shield, if the potentiometer is rotated in such a position that we don't have contrast. So for this, use a screwdriver and carefully adjust the potentiometer to such a position that you get good, nice contrast. From the display. Adjust until you're happy with the result. So this potentiometer will make sure by rotating it to have a good visibility of the text on the display. So that's it for this. As I said, this is very simple test project. It switches here between flashing display and permanently on display. And the rest of the buttons simply will display their value. Now it's time to start working on more interesting projects with this shield, probably in combination with other shields.